Hello out there, Physics 277 students and YouTubers who may have stumbled across this video. This will be video 7 in the series that I'm making on how to use the Bash shell, the basics of how to use the Bash shell. And today I'm going to be talking about shell variables and environment variables. We'll talk about what they are and why they're useful. So we'll start off talking about shell variables here. What is a shell variable? Well, many programming languages, and the Bash shell can be thought of in some sense as a programming language, although that's not what it's primarily intended for, have the ability to have data objects that hold values, and that's going to be true here in the Bash shell. So a variable within a Bash shell is going to be this data object that can hold a value, but it's kind of limited in what it can do within the Bash shell compared to other programming languages in that it can only hold integer values and strings of characters. So let's show you how this works by showing you what the form of a statement that would create a shell variable would be. And I'm going to use my shell window here, and the shell variables are going to be set up with what is called an assignment statement, and it's going to be something of the form where we have some variable name here equal and then some value. So the statement will always have this form. There'll be some variable name on the left side of the equal sign and some value, which will either be an integer or a string of characters, on the right hand side of the equal sign. The equal sign functions here not to indicate equality, but to indicate assignment. That is, the value that's on the right hand side will be assigned to the variable on the left hand side. The equal sign is used as an assignment operator in many languages, including C++, Python, Fortran, and so on. So it's not out of character here for it to be used in this sense in the Bash shell. So let's be concrete here and show you an example of this. Let me pick a variable name. I'll pick x. And I can say x equal 1. And what happens is when I execute this assignment statement, the variable x is now created and a value of 1 is assigned to that variable. How could I find out what value is stored in the variable x if I didn't know? Well, there's an operator that the shell uses in order to get back the value that is stored in x. And that is the $sign operator. I could say $x and it will give me back the value that is stored in x. Right? Now, if I just execute this, we're not going to get a happy result. What's going to happen is we get an error message from the shell saying 1, command not found. That's because when I said $sign and I applied it to the x variable here, in its place it returned the value of 1, and then the shell tried to execute a command named 1, which doesn't exist. That's why it said command not found. So how could we find out the value that's stored in x without having to actually execute a line like this where it's going to give me an erroneous answer? Well, there's a way to do that using something called the echo command, and you've seen me use the echo command before. The echo command does nothing more than return the value of its argument. So if I say echo and I say ABCD, it returns ABCD. If I say echo 1, 2, 3, 4, it returns 1, 2, 3, 4. So what I can do is I can say echo $x, and it will return the value that $x returns, which is going to be 1. So I can use that to ascertain what value is stored in the variable x. This is why you saw me back on one of my earlier videos where I told you could find out which shell you were running by saying echo $question mark like this. I'm sorry, $0 like this. And it came back and it said bash, and I said that tells you it's running the bash shell. Why did that occur? Because 0 is the name of a shell variable that holds the name of the shell that's executing. All right, in this case, it gave me back bash. All right, so that's how we set shell variables. What are they going to be useful for? Well, various commands can actually execute shell variables. Can access shell variables, I meant to say, that get the values that are stored in them. And that can control how commands are running. All right? There's several ways that you can do this. We're not going to concern ourselves about how to do that in this class, but let me just establish that that's the case. And let me show you a example of this. All right, I'm going to cd into my SB files directory. Oh, I'm actually, I believe I'm already there. Let's do a pwd to print my working directory, and I am. All right, so I have a command here that I've written called my command. And what it does is it looks for a shell variable named capital X, and it returns its value. Remember, the shell is case sensitive here, so if I have a variable like little x equal 1, that's very different from a value of a variable named big X equal 2. They're treated as two completely different things. Now, this command, my command, looks for variables that are named capital X, and it prints out their value. Let's see if it works. I'm going to run it by typing /my command. More on that later, why I'm running it this way. And it says capital X has the value and returns nothing. All right. This brings up an important point. If a shell variable is unassigned, has no value assigned to it, when you say $, and that shell variable name, it returns blank. So if I say echo, for example, $capital Y, all right, and it returns nothing because there is no such shell variable, or a shell variable doesn't have a value assigned to it. Okay, so that's interesting to know. What do we do about that? Well, we're going to work on that. Give me just a second here. First of all, I want to talk about this business between upper and lowercase names. The convention we use is that when we create shell variables, we name them in lowercase. All right. So why am I having this uppercase X value here, or uppercase X variable name here? We're going to use a different convention, which is when we create something called an environment variable, we're going to use uppercase names to indicate that it is an environment variable, not just a shell variable. I'll talk to you about the difference between that in a second. Here's the issue. If I say echo $capital X, I get back 2, so that clearly exists. Why didn't my command here be able to access that? It's because when I set a shell variable, that shell variable exists only within the bash shell. When I run my command, what happens is the following. The bash shell takes my command that I'm executing here when I type enter, and it starts it up as a new process running on the computer. And all the shell variables that are defined within the bash shell here are not available to that new process. The only way that I can make shell variables available to a new process that is started by the shell, or spawned by the shell is what we normally say, is to place them into something called the command execution environment. All right. Usually people will not use that terminology, they will just say the environment. The environment you can think of is kind of a space where we can place variables such that any process that is spawned as a child process can access them. So if I want to be able to access that value of capital X equal 2, right, I need to place that capital X variable into the command execution environment. And the way I can do that on Linux and Unix systems is to use a command called export. I can say export and then the name of the variable I want to export. And when I execute this, it now places this variable capital X into the environment, that is the command execution environment. I can see it hasn't altered the value of X. I can execute $capital X again and I get back 2. But this time when I run my command, it says X has the value of 2. All right. Similarly, if I create Y here and give it the command or the string dog, right? At this point, Y exists within the shell, but it doesn't exist within the environment. So any child process that is started by the shell that would try to access Y wouldn't be able to access it. All right. And if I wanted to make it accessible to child processes, I would have to say export Y. Right? Now, if I had some sort of command that executed and basically attempted to access Y, then it would be able to do so. Now we can combine these two commands, the assignment statement and the export, into one step. When if we want to create an environment variable, let's create an environment variable called z. We could say export z equal, and then the value we wanted to set it equal to. Let's say bird. Okay. So now there's an environment variable within the environment that's available to any child process of the shell. How can you find out what environment variables are there that are available to child processes? Well, there's a command called print env, print environment. And if I execute this now, it gives me a big long list of all the environment variables that are currently set. And you'll see it has x equal 2, y equal dog, z equal bird, and it has all these others, many of which I don't even know what they're used for, honestly, and there's no need for me to do it. Some of them I do. Here's a good example. User is an environment variable that has the username of the current user. All right, so in this case it says dswesty, which is my username. pwd is an environment variable that has my present working directory, that is my current working directory, stored in it. And as I change my directory, this will change as well. All right. Shell here is an environment variable that tells me what shell I'm running and what its absolute path is on the system, and so forth. All right. Here's one called PS1, which sets your prompt, and I have my prompt set to this prompt you see here. It's going to be different from yours. I recommend not messing with yours if you don't know what you're doing. A very important one is this one called path here. And we're going to talk about that, and that's the principal reason behind why I'm talking about shell variables and environment variables here today. Let's see what the value stored in capital path is. All right. It is a string of directories separated by colons between them, here, 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 and so on. All right. They're absolute path names to the directories, and they're separated by colons. What is this used for? The shell itself uses this. What is it? It is a list of directories that when I type a command into the shell, it searches for these directories in order to find that command. So when I type the command ls and I hit enter to execute it, what happens is the shell starts searching. It first looks to see, can I find ls in this directory? If not, then try to find ls in this directory. If not, try to find ls in this directory. If not, try to find ls in this directory /user/bin. Then it will try to find it in /bin, and it will try to find it in /bin, sbin first, and then bin, all right, and so on. All right, it's just a list of directories that the shell searches for commands. Where does ls actually live? Well, we talked about that in the last video. We can use the which command. We say which ls, and it searches through the directories until it finds ls living in the /bin directory. So that's 1, 2, 3, 4, 5, 6. It's the sixth directory in this list where it finally finds ls. As soon as it finds an ls that is executable, it will stop searching through this and it will execute it. Okay, so that's very interesting. This also explains why when I had to execute, let me do an ls here now, when I had to execute this command that I wrote, my command, all right, why I had to execute it by typing /my command. Because when I type, if I were to just type my command here right now, it would say command not found. Why? Because my command is not in this list of directories anywhere. All right. My current working directory is not in this particular list of directories. Let me show you again what that list of directories is. It's echo $path, all right, gives me that list of directories. So if I wanted to execute my command by just typing my command in the same way that I type ls, all right, I would have to add my current working directory to that. All right. One way I could do that is I could get my current working directory, I could say pwd, and I could append this directory onto the list of things here and set the path equal to that, and that would work. But what happens if I change directory to another directory and I have a command there I want to run? Then I would have to change the path variable value again. All right, that would be a pain in the butt to do that. An easier way to do this is we have a symbol within the shell that represents the current working directory, and that is dot. Remember, we talked about that in the last video. Go back and look at video 6 where I talk about or one of the previous videos where I talk about, I don't believe it was video 6, but I talk about absolute paths, and I talk about relative paths, and I talk about the dot symbol being a symbol for the current working directory that the shell uses. What I could do is just append a dot onto the beginning of this, all right? And that would be an easy way to do it, all right? So what I could do is I could do the following. I could say capital path equal dot colon, and then this whole long list of directories here, like this. And if I hit enter, this will work, and it will automatically be able to use any executable file that it finds within that directory as though it were a command. All right. I'm not going to hit enter though, because there's an easier way to do this. I don't want to have to type all this long thing. It's very prone to typos. And by the way, here's a very dangerous point. If you mess up and make a typo in setting your path variable, your shell will not be able to find commands. All right. So you really don't want to make that mistake. What would have to happen is, and I'll show you, I'll purposely do this in a second. I'll make a mistake in doing it, but it would create a problem. There's a better way to do this. All I wanted to do was take the current path and stick a dot colon on the front end of it. All right, so it searches my current working directory first and then tries all the other directories subsequently. How could I do that? Well, remember that when I type $path, I get back a list of directories, right? Like that. So what I could do is I could just append a dot and a colon onto the front of that and assign that back to the variable path again, like this. I could say path equal dot colon $path. Note that I'm not putting spaces here between these things. That's perfectly fine if you're doing C++ or Fortran or Python. It does not work in the shell here. You don't want any spaces on either side of the assignment operator. But when I do this now, let's look at what the path variable holds in it now. I'll say echo $path. Now you can see my path string here has a dot colon on the beginning of it. Now I shouldn't have to type / in front of my command anymore when I run it. I should be able to just type my command, and indeed it works. All right. So this is a very useful thing to do. Now, the downside is to this, you would have to do this every time you logged in. So what could you do? Well, in the previous video where I talked about setting aliases, I talked about how you could establish an alias permanently by putting it, if you're on a normal Linux or Unix system, in your .bashrc file that is in your home directory. Or if you're on our MATLAB systems here at Stony Brook, where student directories are mounted in MySB files, in that MySB files directory, there is a mybashrc file. And in fact, I have one here. How could I do this? Well, I could take this command, path equal dot colon $path, and I could basically put it into my bashrc file here. All right. So let's do that. We'll emacs that. If you haven't seen my videos on editing emacs, you will need to know how to use emacs to do this part. We'll say emacs my bashrc. All right. So I'll go here, and in there I will say export path equal dot colon $path. All right. I'll save this, and I'll exit emacs, and there it is. Let's just double check that that got set. We'll use the cat command on my bashrc here, and indeed you can see there's the line that I did. Why did I put export here when I didn't do it in the shell? Here's the reason why. This file, the commands in this file are executed when you first log in. There is a process that logs you in. Any shells that are created by you subsequent to logging in are child processes of that login shell. So when we set this in my bash RC here, or your .bash RC if you're working on your own home Linux system or your personal Linux system, that is a shell variable that is set in that login process. We want it to be available to any child processes, which include any shells that are started up when you log in. So that's why we put the export there. We place this path variable into the environment, and that's why when you first log in, if you type print_env and look at the list of variables, that's why you see this path variable with this assignment of all these directories that things are being checked for. Okay, so that will do it, except you have to log out and log back in for this to take effect. All right. So I encourage you to try this, but what I would do is, if I were you, I would try setting your path to this first before you put it into your bash RC file, and make sure it works. Make sure that you can type all of your same commands. Let me show you how you can mess up here. All right. First of all, let's look at one I'm going to need here. Let's look at a command I'm going to need. I'm going to say which log out. All right. This doesn't say anything. That's because it is a bash shell built in. All right. Let's say which ls. That's /bin/ls. Let's say which emacs. All right. This has an absolute path to it of user bin emacs. Now, I'm purposely going to mess up my path variable here. All right. I'm going to say capital path equal XYZ. All right. Now, let me try to type ls. I get this message that says command ls is available in /bin ls. Command cannot be located because /bin is not included in the path environment variable. This version of the bash shell is very friendly. It kind of tells you, essentially gives you a hint at what's not right here. All right. But if I tried to type ls, I couldn't do it because my path variable is now all messed up. It has basically this value of XYZ in it. All right. Similarly, if I tried to type emacs, it wouldn't work because emacs is no longer in my list of path directories to check. All right. But this shell is kind of friendly. It's telling you that you could execute it by typing /user/bin/emacs. Some versions of the bash shell you have on some systems will not do this. All right. They will just say command not found, and you'll be wondering, what do I do? What do I do? What do I do? All right. In this case, if I wanted to run emacs, I could run it by typing /user/bin/emacs, and that would work. Okay. All right. If I want to log out, I can still type log out, and if I log out right now like this, all right, I logged out of the portal system. Let me log back into the portal system. All right, put in my username here, and oh, I'm already had my username there. Let me put in my password. I'm logged back in, and fortunately my path variable is okay because I didn't mess it up in my bash RC file. I messed it up by setting it in the shell directly. So as soon as I logged out, that was wiped out, and when I logged back in, it executed the line that I had in my bash RC. So let me just CD back to my SB files again for my Physics 277 students who are looking at this, because I want you to not make mistakes when you do this. If I do a cat on my bash RC, let's look at that line. It goes in there. It's export path equal $path. No spaces here around the equal sign. All right. If you put spaces, you could have a problem here. So I'll stop for now. We'll talk more about using the bash shell next time. If you have questions and you're one of my Physics 277 students, please come and see me at office hours, reach out to me, or even shoot me an email. If you are watching this video out in YouTube land, please feel free to post a comment and I'll respond to it. Otherwise, if you like the video, please give it a thumbs up. If you're interested in more of these, please click subscribe, and I'll see you here next time.